Okay, now let's look at the parameters for non-interactively generating a decision tree. Okay, so the first one. So here are the splitting rules that you can look at, right? So if you have an interval target, okay, so for an interval target, so these are the possible statistics that you can use to determine the purity of the splits. If you have an interval target, then you have a choice of probability of F. Okay, probability of F, prob F is your chi-square. Okay, so when you split, you look at how independent the two nodes are, and that's that. Variance is the variance between and within the nodes. Okay, so you can use either one of those criterion. The chi-squared value, prob F, is your default. Now if you have nominal target, like what we have in this case, okay, again we have the three possibilities are probability chi-squared, so that's your log worth. Okay, we did log worth in our when we did the computations in Excel, and we did entropy and Gini as well. So you can select any one of the three, and for SAS Enterprise Miner, log worth of probability of chi-squared is the default. Okay, and ordinal target entropy or Gini. Okay, now significance level is for the candidates or the candidate splits, okay, the ones that we want to consider. It should have at least 20% significance level. It's not, we don't use 5%. We're trying to not overlook any possible splits, so we set the limit as 20%. If significance is more than 20%, then those splits are not considered as possible candidates. So that's our default. You can change that if you like. The missing value, okay, the default is used in search, so which means missing values will be used as like what we saw in the interactive tree. It will be used as a possible value and used to branch. Okay. Use input once. Okay, you don't want to do that. Okay, use input once is once you use a particular predictor like income. We did in the interactive tree. Okay, we use income at the top. That was the first one we used. So once we use it, then income is never considered again for possible split, and that really restricts our search for a good tree quite a bit, and therefore we don't want to do that. But SAS gives you the option to say use input once as a yes, but default is no. Okay, maximum branches. Okay, from a node, maximum branches. When you have two, then what does that mean? We have binary split. Okay, so that means we only consider binary splits. Okay, remember that we can have more than binaries. We can have 3 splits, 4 splits within, from a given node. Okay, and usually we want to use binary split. So 2, maximum depth is going down from the root tree, from the root of the tree. So you go down how many levels? So it says 6 is the default. You can change that also. So minimum categorical size is for a nominal predictor. Okay, a particular category must have at least a certain number of observations. You remember we talked about these in pruning. Okay, so if it has less than, so 5 is the default. So if a particular category has less than 5 observations in it, then that particular category, that particular level of the nominal variable would be coded as missing value, and it will be used as a missing value in the in branching. Okay. Now here there are pruning. There are 2 ways in which we can prune. One is top-down pruning. Okay. As you go from the top, okay, you apply these pruning rules, okay, like this, how many leaf size, okay, leaf size is a particular node must have at least 5 observations in it, okay. Otherwise that's it, you're not going to branch from that node anymore because it's already too few observations there, so you don't branch further down from that node, okay. Things like that. So the maximum depth is again top down pruning. You're limiting how far down you want to go, okay. Use simple maximum category size. These are top down pruning, and then we will look at bottom up pruning, okay. We'll look at that in just a second. And surrogate rules, okay, right now number of surrogate rules is 0, but you could have, like, the primary rule is income less than 68,000, greater than or equal to 68,000, right? You can have a secondary rule from that. If certain conditions are true, the secondary rule will be applied, but that makes it too complicated. So the default is no, the secondary rule is no. And then you can have the split size specifies the smallest, so if you, here it is, specifies the smallest number of training observations that a node must have for a procedure to consider the split, okay. And split search, so here is use decisions, okay. So this is where you will say yes if you had set up decision parameters. Remember when we set up the data source, the step 6 of setting up the data source was the decision weights. If you have decision weights set up, this is where you can select a use decision, okay. So let's go ahead and select decision, yes, all right, okay. Subtree. Now this is again the pruning. This is again how far down you go, all right. Top down pruning. Assessment would be based on assessment value, okay. Whatever the assessment rule is, okay, and that value will be used for pruning. Now largest is no pruning, it just will, create the largest possible tree for the data. N is number of, the how many you want. Method, let's see. So N selects the largest subtree with at most N leaves. Okay, so leaves is your terminal node. We want 10 terminal nodes, then you put 10. Usually, you want some kind of assessment to decide where to stop, because you don't want to arbitrarily decide, okay, I want 10 nodes or 15, 10 leaves or 15 leaves or whatever. Okay, and the assessment measure, okay, so this is the assessment measure: decision, average squared error, misclassification rate, lift. So these are the possibilities. Of course, for you to select decision as the assessment measure, you should have set up your decision weights. If you don't have the decision weight set up, then decision is not going to be the one that you would use. All right. So once you have set all that up, then you can run the decision tree node. Cost variable or value cannot be specified. Some other problem. Well, anyway, that's not important. Let's look at. Okay, I'm going to put it back to no. All right, so let's look at results. Okay, so it gives you the cumulative lift, and all of this we have already discussed these previously. So it gives you all of these charts, right? And here is the tree. Okay, so you go to view and fit to page, and it gives you the best tree. And here, by the way, the how the nodes are color coded for purity, right? So here this dark blue, this dark light blue, dark blue. Okay, so dark blue here indicates that it is really pure, because see, there is 100% 0 for both train and validation set. See, so this is a completely pure node. This one is not that pure, right? So 83 and 82% 0. So you see a slightly light blue. Okay, so there is no color at all, and then it is very impure, because 65% and 63% is 0, 36% 1. Okay. Now for the terminal nodes, you can, alright, so here if you go to display English rule, so that will display the rule for that leaf. So where income is greater than or equal, so it starts from the root node and describes the path that will get to that particular node. So that's the English rule for a given node. Okay, so now let's look at the output here. So it tells you what the target is. All right, and here is the decision matrix that we entered, and here is the tree leaf report. What is the node ID of the tree leaf node? Okay, what is the depth? How many training observations, and the training percentage of ones. So number of validation observations and percentage of ones, okay, in those leaf nodes. And here we have the statistics for train, validation, and the test data set. So here misclassification rate, say right here, and sum of squared error, and then total profit. So the total profit, okay, this comes from what? How is the total profit calculated? Based on the decision weights that we entered. Okay. And then of course we have the classification matrix, the confusion matrix statistics are available here. All right. All right. Thing is, you don't get the confusion matrix statistics for test data set. It gives you only for train and validation. So to generate, I think we did this previously one time, right? To generate the classification matrix for the test data set, you have to set up a SAS code node and generate the table.